Welcome once again. We're going to continue our discussion on interpreting infrared spectrums. So I'm going to load these two because this is the first time this is the first time since I've shown you a spectrum. I just want to take like 2 seconds and then walk you through the X and the Y axis. Now the Y axis is the percent transmittance, that is how much radiation is transmitted through the cuvette containing the sample, right? That's one thing. That's the y-axis. Now wave number is the x-axis. What is this wave number? It's inverse of frequency. Okay, so you know frequency is this is frequency, right? Wave number, okay, is nothing but 1 over frequency, right? And there's also something I want you to take away from any spectrum is there are 3 major kinds of peaks: strong, medium, and weak. Strong typically means it literally fills that particular peak, literally is very, very long, from all the way to 100 to almost 0, or at least it fills up more than 80% of the graph. Medium is typically just like it's medium, 50% probably would be the length of the peak. And weak would be probably 10–20%, is almost at the very top, right? So something like this would be a weak, okay? And something like this would be a strong. This could be strong as well, and this is definitely strong. So peak that are like almost, I would say this is maybe, yeah, I would say this is strong. Medium's like right about 50. So this is strong peak, right? I just showed that. So keep that in mind: strong, weak, and I can't really see a medium over here. You know, this is still weak. Medium's right about 50% or so, right? Okay, so when I give you a spectrum, don't get flustered and then start looking at everywhere in the graph, because then it beats the purpose of the tool, okay? You have 2 groups. All you got to first look at is have the table in front of you, okay? Find out what major strong peaks you have, okay? I'm going to mark this as 1 and 2. There are some characteristic peaks, okay? And 1, literally, you see these peaks are filling up the space, right? So 3, maybe this one right here, and maybe this is 4. You know, don't do too many, don't do more than 4, because normally you can get away with just doing 2 or 3 at most. 1 or 2 would even help you narrow it down. Now, if you look at this first peak, it starts somewhere, this is 3000, so it kind of starts maybe around 3500, 3600, right? This value is 3600, right? This is 3000, and it sort of goes all the way to maybe 2200, something like that, right? That's a long peak. Now, there is only one thing on that table will give you that, and that is you have a OH stretching, which is the largest, but you see that table specifically tell you whether that OH came from an acid or from an alcohol or just from water, right? You see that clearly, that peak from 3600 almost to 2500 corresponds to the OH in an acid. Right away you know this is A and that's B. Now how do we know this is B? This is an alcohol, right? This is the functional group. This is an acid functional group, right? Right? So this is 1. Again, this sort of test tube looking peak, that's classic alcohol, okay? This sort of wide looking peak is also alcohol, but it's in an acid, right? If you see this is around, if you draw a line, it don't have to be perfect, it just have to be approximate. It's around 3100 to about 3600, right? Or 3500, it doesn't matter. About 3600 or 3500 to 3100. I'm just making these, round these values up, because no one's going to ask you to write these values down, okay? So right away we know this. There is another important aspect, which is this peak. Now say you still can't figure it out. As I said, go to the second big one, which is this. This peak is at around 1700 almost, right? That peak is missing here. Now anything around 1680, 1710, typically in this range, is a carbonyl group. That's a C double bond O, whether it's an aldehyde or ketone. But I think I have specifically made it whether it's aldehyde or ketone. You can even get that information, but they're so close that you can't really make those out. But because this contains the OH, which is, this is just for the OH in the acid, this is the C double bond O. So we have two ways to conclude that this should be this, and this is missing that ketone group. So again, I want you to pick the major peak. Now almost this 2 would typically be in most compounds because that's from a CH stretching. Okay, if you see, it's around 3000, say 2900 to say 2800, right around there. This tooth-like looking thing, it looks like a tooth, right? And this is usually a CH stretching. This is almost present in most molecules. It is here, but you can't see it because this peak is so big, it's kind of overlapping on top of that. It's like an eclipse, you can't see it. So this peak, whether it's strong or weak, it's usually also in most molecules. So this is not a giveaway. It's only peaks 1 and 2 here, and peak 1, and peak 3 is around 1580, right? If you see that, that says you can actually go look this up, and it could be that CH2 bend. This could be the CH2 bend, which is around 1480, something like that. This is a CH2, remember? So again, those are very supplementary. It's what these peaks always in the left hand side of the screen, those are the giveaways, right? So we know which one is which. It took me 10 seconds. I think I've said more since I've actually told you the answer, which I took literally the first 30 seconds of the video. I was already on the answer, right? So don't fluster. Again, peaks are listed as strong, medium, weak in the table. All you got to do is find 1 or 2 things that is usually common. Now this peak on the 2, this right here, folks, this C double bond O, that's a classic. So is that large peaks, right? That's classic. And then the tooth-like looking thing is also very, very classic. But the tooth-like looking thing just doesn't really give away much other than it's a CH, which almost every organic compound contains a carbon-hydrogen bond. So it's these unique peaks is what you're looking for. Let's do maybe one more example in this video, right? I have 2 more. Which one is which? Didn't I just not say that? Like this is usually C bond H, okay? C single bond H. Now this molecule does not even have a C single bond H. They're all double bond, right? I mean, there's a double and a triple. There's no C single bond H. So this is not going to be what we're looking for. But, well, you can argue, well, maybe this could be the single because it's resonance. Okay, fine. As I said, this is a clear indication. What is it? 15, 16, 1700. This is very, very strong, and it's usually an aldehyde or a ketone that corresponds to a C double bond O. Right away, we know this is our structure. Bingo. Now, there is a C triple bond N. If you go to the table, should be a really, really strong peak at 2250. There you go. 2000, 2100, 2250 right away. These peaks are very, very strong. So all you're looking for is, you see how quickly I got there? Now, trust me, this tooth-like looking thing is only CH, okay? This is benzene, which is usually not the case. So we know right away, this is this, that's that. Again, it took me less time to actually figure out what it is than the time it took for me to actually go into more rational. So what I would probably, one way for me to ask this on a test is I give you a spectrum. Maybe I give you values and said, which of this would be a correct statement? This value corresponds to this. That's one way. Or I can give you which peaks can be obtained from it. I will not give you close calls. You see, all of these guys are so close. There may be some commonality. So I won't dig deep into all these close looking peaks on this side of the sea. All of these, there's so many close calls here. I wouldn't put you in that spot with that. I would only go for the key markers that allows you to identify one molecule from the other. I got one more. We go. This again, this tooth-like looking thing. Again, I keep saying that. The C triple bond C. Now, if you see that this tooth-like looking thing is not before 3000, it's actually after 3000, right? Right? So it could be this. If you see C triple bonds, the CH stretch is around 3300, which is what this is, right? And it's a strong peak. Well, this certainly looks strong. But then this one does not have the C double bond O, right? Well, so you see, this could also be the C. You see, there's the C triple bond C, and then there's a CH stretch. This is around, this could be that it's probably just weak. But so there's also the CH stretching, which is the tooth. This again does have a CH, so this won't help you decide whether it is this or this, because they both have CH stretching. And this is, folks, is the, I think this is the NH stretching. If you see, it's not C triple bond C CH stretch, right? It's not the CH stretch because that's just 3300. There's no two peaks, right? The NH stretch is the one that's two peaks, 3500 to 3350, right? So this corresponds to that, but then the real giveaway is this. This is a C double bond O, which is around 1700, which is what is found here. So this is the NH stretch, okay, which is a strong peak. This is a C triple bond H, and then there's also a C triple bond C stretch, which is around 2260, which is, well, not seen much here because you can see in that it's variable, right? It says 2100 as well. There's no real peaks here. That's not a giveaway, right? So this peak, we can only eliminate it by choice, that this couldn't have been this because this is missing the C double bond O. But this has two strong variables, the NH stretching and the C double bond O stretching, whereas this only has the CH stretching. But it does say it's variable, right? Again, you got to use the table. You cannot memorize all of this, right? So I know this is this and this is this. This is probably my least favorite molecule example I've given, but I've shown that just to show you how occasionally it may not be a clear cut, but when you compare two things, it's going to be easier, right? Again, I don't remember the table. I used the table to figure this out, right? So you'd have to use the table to figure it out. Typically, if you look on more of the left side of the graph, that's where the heart of the information is. Now you may wonder, what is this thing here? This peak right here, right? What is this? Well, it's about what, 1400. If you go to the table, 1400, 1440. Well, that could have been, there could be a lot of things, but if you think about it, let's see. Well, it could have been a CH2 bend, right? Because there is a CH2 here, right? This is a CH2 bend, which is around that 1480 to 1440 range. There is no CO, so we won't have that peak there. But then there's more ways to justify this than the other one, right? So again, that's what, again, this is again that same 1480. Again, this is that CH2 bend, because you see this does have these CH2s, right? But again, that's not always a giveaway. That's why I keep telling you, look on the left side of the graph. There's more markers than looking to the right side of the graph. You only really use the right side if you're really on a tight race. All right, I'm going to stop this video here. I think I got 2 more examples which are very unique, and then I'm going to leave in that same video a practice problem for you to practice. And we'll first leave this here. This is all I want you to take away from IR for now, and then in class maybe we can add a few more things to make it interesting, right? So stay tuned for one more video.